Doing some Cal 1, and we're finding indefinite integrals. There's a tricky one there. We got the integral of dt. You know, that's kind of like something you'd see on a test, I promise. And a lot of students, believe it or not, would miss it, so that's the reason I threw it up here. And we got the integral of 5 dt and the integral of all this stuff. So you ought to try pausing the video and getting the solutions to these guys, coming back, and let's compare answers. So we start with the integral of dt. Now, there's a 1 in here. Okay, so this is really the integral of 1 dt. So don't let that confuse you. All right, the variable of integration this time is t. So I've been using the variable of integration as x. So, you know, in class, the teacher may work out a bunch of, the variable of integration may be x, 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 and all of a sudden on the test you see a t and you're like, whoa, what the heck's going on there, Nelly? Okay, well, it's just really this simple. It's just t plus c. Now remember, you can take the derivative of this and you should get back 1. Okay, take the derivative, get back 1. All right, what about the integral of, what was 5, I think it was, 5 dt. So this just ends up being 5t plus c. Right, so we can take the derivative of this and get back 5. All right, let's go and now work some more serious problems, even though I guess those could be serious if you were to miss them on a test. But a more complicated problem, I should say. Let's see, x squared plus x plus 1, and it's all over the square root of x. And you're probably saying, oh my God, I'll never get that right on a test. Sure you will. First thing we got to do is rewrite this thing. So I'm going to, of course, break this up. And then I'm going to, let's see, get that out of radical form, get it into exponential form, plus x over x raised to the half power plus 1 over x raised to the half power. Let's put some brackets around everything. I could have put parentheses, it doesn't matter. And then of course we have dx. So we're still rewriting this thing before we can actually do any integration. We're going to bring that to the top. So this is x squared times x to the negative a half plus x times x to the negative a half, and then plus x to the negative a half. Let's put parentheses around everything and a dx here and the integral there. All right. Well, we're getting there anyway. Adding exponents. So we have 2 minus a half. That's going to be x to the 3 halves, right? I'm thinking that right. Plus x to the half. So we hadn't done any calculus yet. We've just been doing a bunch of algebra. And that's usually the way calculus is. You spend most of your time doing algebra. Ugh. All right. Okay, finally we've gotten somewhere. I should have been writing equal signs out here to the left. So what do? We add 1 to the exponent, right? So this becomes adding 1 is 5 halves. And then of course we put the 5 halves down here, plus add 1 to a half, and you get, what do you get? 3 halves, right? Plus, and then we add 1, and you get half, and then put the half down here, and then plus c. All right, well, let's do some stuff. So we're going to flip that fraction. That's 2x to the 5 halves over 5 plus 2 over 3 times x to the 3 halves. Now you notice I rewrote that differently, but that's okay, it doesn't matter. And then 2x to the half plus c. And then you probably want to get this into a radical form and out of exponential form, and I'll let you figure that out. That's a 5 right there. Man, what is going on? Okay, so good luck.